Welcome back to School of Physics. In this lecture, we are discussing about the Newton's third law of motion, because in the earlier sections we have been talking about the first law of motion, the second law of motion, and now it's the time to discuss a few things about the Newton's third law of motion. So till now we were discussing how to calculate force. This was given by the Newton's second law. Okay, if a body is there, if we are applying a force onto it, how to calculate that very force. For that we should be known about the acceleration, velocity stuff and all that. We can also calculate from that by using the impulse. Okay, so now what about if a force is acted onto a body A? Suppose this is a body. There are two bodies. This is a body A here, this is a body B here. If, for example, what about the bodies if we apply a force onto this by some agent? Okay, we can calculate the force, and this in turn means that is there a possibility that B is also applying a force on something A, if it is applying force onto this? Say, for example, what I'm saying, this is quite observable in some cases, like if this is a spring and I am applying a force like this but with my hand. Okay, if I am acting a force onto this, it will be compressed like this. Now we'll feel an outward push by this spring. Okay, that is the spring force which I discussed earlier. If I am applying force with my hand, I will feel a similar force from the spring outwards. Okay, so in that case, I can say that, oh yes, the spring is also applying the same force upon my hand. But what about the two bodies which are at a distance, still applying a force upon each other? Okay, say this is a body which is called as the Earth. Okay, this Earth, and some stone is dropped from here under free fall. Okay, we know that it will get down because there is a kind of gravity there, and it will be accelerated under the effect of the gravity, and the gravitational force will be applied onto this body. What about this very body? If this is a body A and this is a body B, what about if A is applying a force on B, that is gravitational force here? What about B? Is B also applying the same force on a body like the Earth? The answer is yes. And this yes was said by Newton himself. He said that even though these two bodies are at a distance, if A is applying a force on B, like FBA, that is the force on B due to body A, then same force will be applied onto the body B, on the body A, that's FAB. Okay, so we have got two bodies, which this very is applying a force on this is body 1, 2, so force on body 2 due to 1, then in the similar fashion, force will be applied on body 1 due to body 2. This is called by the Newton, and is famously called as the Newton's third law. That means what Newton in mechanics says that it is always happening in nature that forces, if we apply onto a body a force, it will not happen singly. There will always be a reactive force, a force generated by that body in turn. Okay, so we can say that forces never occur singly. Okay, singly in nature. Fine. And that means what? That means forces are always generated in pairs. Forces are always generated in pairs. Okay, they occur in pairs. And another thing he said that it's not only in the pairs, but there is a generation of the equal amount of force, but in the opposite direction as that of here. If this force is applied onto this in this direction, then the same force will be exerted back, but in the opposite direction. So there is a mutual forces between the two bodies. There's a mutual there. I can write it like this: the mutual, because this is same force applied this by this body onto this, and in turn this will act in the similar fashion. So mutual, there will be a kind of relation, like mutual relation. Okay, mutual forces between two bodies are what? Equal and opposite. This is the main statement which was given by Newton, that the forces are generated by both the bodies. If first body applies a force onto the second, then in turn force generated by the second will be same as that of the first, but in the opposite direction. That will be equal and opposite. So he gave a statement which is famously called as the Newton's third law, and is commonly used by the common pupil also, not only the physicist. And that is the third law of motion. Third law of motion. I will write it down like this: to every action, there is always an equal and opposite. These two terms are very much important. Equal and opposite reaction. Fine. These two terms. There is always an equal and opposite reaction. So to every action, there is in turn a reaction. Okay, a reaction is generated in the back. Okay, so third law says that if a body A applies some force on body B, then in turn B applies a force on A, but that will be equal but in the opposite direction. So there's a kind of action and reaction relation between the two, but there are few wrong impressions. Now I will be talking about the wrong impressions which are among the pupil about the third law of motion. First, we know that two bodies are applying, if one is applying a force onto the other, the second is applying the same force in the opposite direction. But there is no cause effect relation. Okay, this is not a kind of stuff like cause and effect. If A is generating a force on B, that is why the B is generating a same force in the opposite direction. No, it is not due to the effect of the A, that it is not due to the cause of the force A on the body B. That's why the effect of B is happening there, that force generated by the body B is there. No, it is not the effect like cause-effect relation. What is the cause-effect relation? For example, if there is a body here, and it's we are seeing an effect inside it, motion. For example, moving with the velocity v. It was first velocity 0, stopped here at rest. Okay, that means it came into the motion because some force is acting onto it. From second law of motion, you are well aware about that. That means there is an effect, but behind that effect there's a cause. That is the force here. But third law of motion is not like that. Among the two bodies, it's not like that. Force generated by body B is because there was a force generated by A onto it. It is not like this caused this effect. Fine. It is not like that. The body A is applying force on B, that is why the B is applying force on body B. No, these are simultaneous effects. These are simultaneous processes, okay? So I can say these occur simultaneously. Fine. There is no such thing like cause and effect. First there will be a cause and then there will be an action, as in the classical mechanics. First there is a cause and after that there is an action. In the classical mechanics this thing happens, but this is not the case in the third law of motion. These two occur at the same time simultaneously. Keep that in mind. Cause-effect relation does not hold here. Fine. So it is not like that first A applies some force, then in turn B applies back after some time for the reaction of this. So this cause and this action and reaction is not like cause and effect. Cause and effect. No. Okay? This is not like cause and effect. Fine. So it is both of these forces are occurring or exerted on each other simultaneously. Fine. This was one thing which is the wrong impression about the third law. And second thing is that the forces, according to third law, we know that, according to third law of motion, we know that force, if there are two bodies, A and B, if this applies a force onto this body, if force applied onto this body B is FBA due to the body A, and in turn the force applied onto this body A by body B is represented by FB, and these two are equal. We know from Newton's third law of motion that FAB is equal to that of the force of reaction, that is FBA, but in the opposite direction, that is a negative sign. Fine. But it is not like that. This relation to be written as FAB plus FBA equal to 0. If we put like onto this side equal to 0, it does not say that the force, that the resultant, this means that the resultant force is zero on one single body. On one single body. These are the kind of wrong impressions. This is not the case. This is wrong. We can't say that the total resultant of the total forces on a body is 0. No, it's not like that. It is this bodies. There are from the third law of motion, we have to consider two bodies, body 1 and 2. This applies something force on this applies something force on this, then the combination of both these two come to be 0. It is not like that the force acting onto this resultant of those forces comes to be 0. No, that's not the case. That's a wrong impression from the third law of motion. It is the force which is generated onto this and the force generated onto this by this body onto this, their sum comes to be 0. We can say that if we combine these two bodies as a whole, and these are inside a system, consider a system like this, in which we have both these two bodies, 1 and 2. Force 1 applied on force 2 applying force on 1, and force 2 is the force applied on body 2 by the body 1. So if we consider two bodies inside one system, then we can say that the resultant of forces, but here in case of this, these are the internal forces. Keep that in mind. For resultant of the internal forces of a system cancel each other, okay? Cancel each other in pairs. Fine. So from third law, this very statement is wrong, but we can say that if we are considering these two bodies the part of a same system, then in that case the resultant of the forces, but here in terms of this system, in the case of this system, this is the internal force. Fine, this is the internal force, and in case of there, we know that these internal forces cancel out each other in pairs. These were few information about the third law of motion. Hope you got it. I will see you in the next.